quick. All right, let's get started. Do I use this or do I use that?
No.
Hello. All right. Hello, marhaba, bonjour. I'm Katie Pickett, and I am from Esri in the United States, and it's a pleasure to be here with you all today. Thank you for staying so late as well. We really appreciate it. We hope to have a very interesting conversation tonight about a number of different things. But first, let me introduce everyone to you. So first, you have Mohammed Isa, who is our regional manager from Esri, based in Dubai. And he'll be presenting first. And then we have Tarak Agag from the Egyptian Survey Authority, the chief of mapping. And then we have Saad Al-Anzi from KSA, Saudi Arabia, speaking about GeoAI. And then we have Professor Reda Yagobi from Morocco, from the School of Geomatics and Surveying Engineer in Hassan II Institute of Agronomy and Veterinary Medicine here in Rabat. So with much further ado, I'll let the folks start. Isa?
Thank you. It's very short. السلام عليكم. Do you prefer بالعربي ولا بالانجليزي؟ انا العربي. يلا بينا بالعربي. خلاص. تمام. احسن. اتشرفت بيكم. انا اسمي محمد عيسى. انا المدير
محمد عيسى, the regional director of Esri. I am honored that today. I'm sorry, he's far from the microphone. Can he? In the cadastral system, and my colleagues will talk about technology and how they will utilize in it. For me, my collaboration with JS as a developer in the cadastral. The certain projects as a developer in Egypt, Namibia, Botswana, Rwanda, in Qatar. Now the cadastral is the first 7 years. I am happy. Probably I will talk about fit for purpose, our perspective. This is important based on what is going in the world. That's where is the slide? أين هي الشفا؟ I was explaining to you, and the slide is invisible. Land administration as a process. As we can see, the land administration or management, there are many projects in one. There is cadastral, evaluation, taxation, 7 items we will be talking about. In each one, in most of the governments, it is part of a department or a ministry different from another one. When we consider the cadastre or land, for example, in Morocco, what is the definition of Morocco? The land of Morocco and the people who live there. This is the definition of it. It is the same state. The core we manage for the entire world. We manage for our own country. And this is the most thing that is impacting on the work. Even when we work on it, 8 out of 10. So people, they be sure for the economy what is important, that the real estate of that, this is your own country. This is the situation we try to explain to people. For the Christopher and others, this is known to them. What is the importance of land management and the cost for society, its impact on economy or on the revenue or the different services. All services are related to the land. Why it is not functional or applicable in most countries? So we always have information, ignoring them. But we cannot gather all of them. Maybe Jalal has information, my colleagues have information, and so each one has information. We need to compound all the information. The matter will be different. Certain countries have been very successful. Without details, I may live in a country, the land that I rent, I would see who rented it before me and who is the owner, how much he paid, when was it bought, and the entire history of the house. So the transparency is not easy to reach it, but it is a trip. When we see the fit for purpose, it is similar to any kind of a project. It is the pyramid. I have time, cost, and the quality. I use the three. If I would like to have a high quality, I can, in short time, I can increase the cost. I try to find what is the purpose, and this is reflecting three things that impact our situation. Anything related to geography, the map, there is part of the legal framework. We are lagging behind in certain projects because of the absence of a legal framework. So the regulation or the regulatory of our process, if it is not prompt, fast, things will be late. This also impacts the institutions. There are 8 institutions and they hold information, how they can collaborate with each other. This is one of the problems. We try most of the time to link the 3 of them. If the 3 are there, things will be great. So we talked about the geospatial framework. How are you going to use it? We have a many technology that will increase geospatial, GPS. I remember 22 years ago, when we work on land, we had only digital maps, and then we survey the land. If you have a satellite image, and I believe my colleagues will talk about it. So, according to the technology, can work on the geospatial legal framework. Where you start, and people. I worked much in Africa. We start with the informal, and we understand the locals, and then things get formalized. We go step by step, especially when you have a large country. Institution-wise, we talked about it much. It depends how you are going to work. You can compare the institutional framework. We try to remove any references within the Middle East because some of the colleagues, they will talk about it. So therefore, I removed our references. This is the alternative way of thinking for the fit for purpose. I think this is clear to all of you. I'm done, I believe. Or I'll be finishing less than this, he said. Our perspective that you have less complex system and a complex one. So you start in where you don't have to go to the most complex system. It is not complex. It is likely, or I need to improve my services. You not to have a complex system to work. There's a simple one. You can work better. You start a small project individually, then we grow. I have a system, multi-system, and the infrastructure for the entire state. And we, as a GS company, we are developed in the GS. Our perspective, most people we work with, it is on land. I have a land, I can put the infrastructure. These are some examples. My colleague will talk about that in details, and I believe we have enough examples. I have removed the references for the Middle East. This is in Colombia. They talked about the example of Colombia. They started small devices. ArcGIS, they work very basically, then they work step by step, gradually. Nepal, they use the satellite image for the identification, then they built on this base. Indonesia, they have another model. The people, they participate. Anybody has information, they share it, and they are given a bonus. Somebody speaking without microphone. They're talking about accuracy. You just need to kick it off to start. Most of the work starts with the beginning, with the commencement. Sometimes what I would like to do, accurate. Before I reach the accuracy, things do develop, technology develops. The challenge, we talked about technology or institution. If you do one of these things, make sure when you take the first initiative or step, the next step, always take the right legal framework. Start with what is convenient to you. You start with something that is very simple, no problem. Whoever starts with it gradually, but surely.
You start where you're at.
انا الحقيقه كنت يعني كان في couple of slides كده عن Esri بس طبعا
Couple of slides. We were that's the example we talked about. The consequence, you can provide good service for the customs. You start to define modernization, working on data. Then we have an integrated system. It looks like a cycle. move from level 1 to 3. Our perspective, we see our system of records. There's a system of engagement through applications and the maps. Last thing, you need to have a system of insight. What is your report? What are the information I have? This is what I talked about, fit for purpose. I wish I could share with you some videos. How much time left? So I use the video to give you the latest technology. Maybe this is irrelevant to what I've been talking about. Let's talk about this, what cover the building footprint. Exact to all the avenues. We have many examples. Swimming pools, because in America they put taxation. The cracks on the road and the pavement. This is a forest. Many purposes, land use. So the AI with the satellite, you can get as many information as you want. You never start from scratch. The future, this is not, this is an application. So this is used by the customers. One day, you like to cover the entire city, its future, with all its infrastructure, the buildings, their usage, our hope in life. So things are working for many customers. Look into the building, but from a different perspective. You split it, and you talked about the integration. There are many cases that I can analyze my own city. The expansive, the posh areas, premises, all this can be conducted. I'm trying to be fast to cover as many information as possible. I can see this building and this part of it, how much will be rent. This is all built. You have a land system. This is, I have a future planning for my city, and I can see how people will live their lives. Now, a perspective to the future. And we started, بدأنا بدrone, drone delivery. The future that use the drones to see the city, its roads, plans. We're seeing how life will go. These are things we'd like to see in the future. So science never stops. Amazing stuff. I'm sorry I've been long. Thank you. May God protect you, said the speaker.
One's okay? This one? Okay. Okay, okay. بسم الله الرحمن الرحيم.
In the name of Allah, the last presentation, the last session, it's about the journey of developing the cadastre by the Egyptian Committee of Administrative Planning. I am Gouda, and I have been working on this for 36 years, and I started in the Cadastral. And among the good thing that Mohammed also worked with me for many years. After that, and I haven't seen him for 20 years until I met him here, especially when it comes to the cadastral. It's a really small world. Whenever in the world you go, you will meet someone and this is from experience. I traveled a lot, and whenever I travel, I meet someone I know. And I took today the topic of the journey of cadastral development and land survey. And what level will AI reach with the cadastral? So, the journey of cadastral development with the committee. The committee was established in 1898, and that in the first register of cadastral in Egypt was in 1904 for taxation mainly, and then the new land survey registers that were modern was made in 1930. Then the personal registration to a certain level until the 1940s. Then the registration was done by the land survey, and then the project of the cadastral started in the 70s. A lot of projects to develop the cadastral in Egypt were made, and thanks to God, I participated in this project to develop the cadastral in Egypt in order to reform the lands. And because it will take some time from me, and I had to start from the scratch and to do the basic work. And each project was done in Egypt. I had independent maps and registers and graphics, but I tried to link all that. And we worked in groups between the land registry, the cadastre, land register, and also land survey, and also link it to the legal situation, so I can link the graphics that were uploaded with the suitable regulations. Then the committee started a project digitalization, and it was very important in the SDI in Egypt. We had so many maps since the French campaign. There were some topographic maps and some maps, and we collected all this data, and the main
كانت واحدة وده
And the main objective is to gather all and to collect all this data. Also, and there was also a cooperation between and the coordination between land survey and land registry. Also, in terms of the municipality is linked to the others, and they are all in the end connected to the cloud that gather the land survey and the land registry. Among the expertise that were done, the registry of the built land, the project of the river lands, and also the project of limitation of agricultural lands. And some regulations and legislations were made to facilitate our cadastral work in Egypt. The strategic objectives of digitalization in the Commission was to organize the geospatial data and also provide the training, capacity building trainings, partnerships with the private sector, and also help digitalizations and linking data in one reference. In 2022, we had the document or the decree of the state ownership policy document. So this documentation was a reference for us and a roadmap of cooperation with the private sector. So if I talk about the history of using programs in the geographical programs in Egypt, back to the 80s. In the end of the 80s, we started using ArcInfo for topographic maps. In the end of 90s, I was one of the graduate of ArcView, and it was linked with descriptive database, and we did an integration between the data in the ArcInfo with ArcView. Also, in the beginning of the 20th century, we started the ArcGIS, and then 5 years after that we moved to GIS Pro. Also, among the good things, there were modules that were providing a lot of works. For example, road and building modules and packages that were ready and that I only have to study and integrate. Sometimes some geospatial images were made available to follow the land properties and also to satisfy the needs of users. Then the last element is the use of AI and the challenges. Sometimes they find a resistance, because if we if we refuse to use the AI, it will be imposed on us. But better to do incentives for people to use the AI. We should comfort people, and the AI will accelerate work and save time, but it can also optimize the human resources. The committee's vision in terms of complete digitalization is that it wanted to accomplish a sustainable social and environmental development. Decision makers with national policies started to do that based on geospatial data and also based on the integrity of the available information like the maps and geospatial maps. Also among the things that we established is to contribute also in the technological development and the strategic aims that are set by the UN. How can I implement, not only implement, but also enhance them? So, the cooperation that was made regarding the private sector by providing a data center and the software, and also to bring new equipment to the branches, and also to do the update of a workflow that will fulfill my needs in terms of technological transition. Thank you.
السلام عليكم ورحمة الله وبركاته.
Peace be upon you all. Your brother Saad Al-Anizi, KSA, we welcome you. We present to you a presentation today in this spatial extension of land. The presentation presents a part before we start. I'm 30 years of geospatial and sourcing the land. It's a hydrological analysis on the spatial extension of land and analysis. It's also it tackles governments that we depend upon a lot, especially lands that are extant, and lands and reviving land. Many things that we see in the conference. Let's start together. Okay. The team is deciding the zones, the suitable zone of extension on the Riyadh region, but utilizing sensoring online sensoring and the systems, geographical systems. And we can add any standards, other standards that need any expert needs in any study, and this make the study and precising the right places. And as an example, the east of the city of Riyadh, as an example. The introduction is the agenda. This is the best microphone. Witnessed many cities in the world, and we have the risks of flows and low places. It's one of the problems, natural problems, that makes expert tired, and we will give examples in our. There are some pictures, as you can see. That takes lives. The importance of the topic is to the study is the focus on the risks of flows and low places, and it is important in the study, and inshallah we will solve this problem. The main problems. Many cities of the world suffers from the millionary in expansions, in problems of civilization, and increasing in the human geographical human capacity and the expansion of this city urbanity. Goes knowing the flows of the waters, and there is a hydrological study that include waters and low places, and categorizing places that are capable of expansion. Questions. There is a scientific study that reflects the goals, the study of zone, methodology of the study. We tackled on the methodology on analytical quantitative methodology. We analyzed the model of the high the increasing the high digitalization, and the methodology is clear. The data, we talk about the data in the last previous presentations. We talked about it. There is a platform. We should create a platform of data, and national platform for data and governments for the field. This platform serves this model. It serves the role and its importance in decision making, and we have the service modifications or satellite image and analysis. There is hydrological analysis, and there is low and high analysis, and results. We have the map of they have two maps. The sources of data. One of the important points that the expert based upon is extracting solutions. He has ideas, but he cannot extract solutions and build any solutions without data. Data is costly, and we have satellite images, and we have on the city of Riyadh. Let's analyze data. We have highs of the zone of the study, and results. The results of the high of high 573, and the lowest place is and two highs and lows. Two highs and lows, we categorize it to 7 layers. The first layer is a low, almost to light, a light low. The analyzing the data. With this map, we have this map that explain. We have 18% of the study which is a very, very low, and the flows of the waters, and for the pools of the waters that finally, last but not least, the map of the distance of flows, main flows of the study, and this is what we talk about, the rivers. This is the rivers. You can choose 1 kilo, 2 kilometers according to the geographical position. 6 is the steps of analyzing the weighted sum. One it means it's 4, and 4 it means close. Weighting sum, and this is, and also neutralizing the area. Results. The final map of the lands of the study. We can show it. We can show it on this table. This table shows zones that are okay, and they are doable, and the zones that are medium, and the red ones that are not they're not usable. And in the case of rain, and we have an extension in land accordingly. This is the new study. Please, the speaker, use the mic. I will give you the recommendations. Of course, we will go to the recommendation. Put standards, hydrological standard and geographical ones from governmentals, without putting any plan. Generalizing this study in all places in KSA before initiating any future plan. Putting channels and staying away from flows and the gatherings of waters and low places after the result of this study. Implementing these studies in places that its growth, and put solutions to the places that are not suitable for urbanization, and putting channels and making channeling the flow of waters. Of course, this is the sources, and thank you. I thank you.
If there are any questions, any of the three presenters? Okay.
Assalamu alaikum.
Peace be upon you. It's true that I have many questions. I will start it with Dr. from the Egyptian division, and I'd say the historical. My question is from 1998. What are the problems that prevented Egypt that will become on its best state. From 1998, they are older than the European countries, but what prevented it from progressing? The second point is the cadastral register. They put together the two divisions, or no, or they separate the two. My question is to Esri, the topic of AI and mobile 3D maps and air photographing, and how we can reach that, how we can, the video that you presented, and the air photoing, droning through drones, it is accurate, or we need another technique, or do we have to present these solutions or not? Thank you. Peace be upon you. The division it's an old division, it's an old council, and they are, I say, the first problem is financing. Finance is a problem. The council, it was a service, it is a governmental one. Until 2002, in this period, there are a lot of projects that been done, and scholarship from Gulf countries in 80s, and these scholarships helped a little bit in improving the council, and one of the sources, the main sources, is a huge chunk of groups of the division. They went abroad: Europe, USA, France, Germany, Netherlands, and other places. It is an explosion in the council. The council has become an economical one, and all its spending is from its resources. This is a problem. This is a setback. Building in the infrastructure in the land. I see that the two should unite together, unify. I see there is problem who to send who. We should. The council has been working for a long time. The part of Muhammad, the accuracy of pictures. This is a question. I want to see the presentation. Let me see the presentation. This is true. The idea of AI, it's good. It's good and helpful. There's something that depends on it. The one thing, where did you get the pictures and how do you put them on? As it is one picture. This is a technology. We have already an application with a quality, and the last thing that I saw, more than 80% on you can get the footprints from the satellites. Also, it depends on the quality of the satellite image and also on other. It's all clouds and other, but again, it depends on the cleanness of the image, the quality of it. But if these topics are available, then we have an option, an additional option, and algorithm. Our sources are open, but anyone can put, a lot of people can put their data, and you can change it, you can edit it with AI, you can change it accordingly. And whether it's the type of the region, there is a random places. They're hard. But I see with the AI, there is an exam. If you can see with your eye, you can precise it or not. With your eye, you see the picture. You cannot select one or the other, or you cannot select it. But it exists. It exists by one click, and the air photographing. It's the accuracy. We talk about its accuracy, and as we can see before, for a long time, there is the satellite. It's accurate, and the quality is accurate, and the space is scary. It's scary. The question is panoramical picturing, imaging. We have in the selective saving 7 centimeter they create from it. When I say the photographing, it's the panoramic photographing and between under drone, and it's accuracy by centimeter. You can move the picture, you can extract from it, scheme it, whatever you want, and what exists as satellite images, technological tools that we have is available, drones, panoramic photography. All the KSA have that. New technologies utilized in many purposes. Thank you. I want to add, most Arab countries they do air photographing. It's utilized by the army. It's old, of course. It's old. The air photographing, not a drone. It's the air photographing. Oh, yeah, it's old. He was used for security purposes, and the matter changed, and people in security, it's changed by the existence of satellites, but the picture, it's slower than the satellite.
Okay, no problem. Yes, ma'am. No problem. Yeah. Okay. So I will start and I will end by 2 minutes. بسم الله الرحمن الرحيم الحمد لله والصلاة والسلام على رسول الله بسم الله والحمد لله والصلاة والسلام على رسول الله وعلى آله وصحبه. So first of all, I would like to ask for excuse because there is a problem in the download. The laptop just updated some drivers. This is why I had this problem. So inshallah ta'ala, in this session, we'll talk about Geospatial Artificial Intelligence for MPC-driven NSDI. I hope that we will have a question-answer session after the presentation. So I'll do my best to finish it within 10 minutes. Okay. So inshallah ta'ala. Okay. So in this presentation, I will talk about the use of GeoAI for the sake of multi-purpose cadastre and how it will help us to update our NSDI. So as you know, all of you, the definition of multi-purpose cadastre is an integrated information system. In addition to the information related to the land, we can add other land-related data, such as, for example, topography, man-made features, cultural features, etc. And the MPC is considered as the foundation of it provides us the foundation data sets for NSDI. And as you know, all of you, the 5 pillars of NSDI that are people, technologies, policy, standards, and data. I will not discuss those aspects because I think those elements are very known for all of you. But I will jump directly to the Geospatial Artificial Intelligence, which is the purpose of our presentation. And I will discuss 3 use cases. The first one, which is related to parcel delineation. So it is an ongoing research project. I have some preliminary results. I want to share them with you and to have discussion about the results. The second one is an already published paper in land urban policy. So it is for forecasting the urban growth, and the use case was for Casablanca city. And the third one, it is a SaaS solution, software as a service solution called MapPerceive, that is used for doing data extraction from immersive 360 images. So all of those are based on geoartificial intelligence principles. Just a quick introduction to what is GeoAI. So GeoAI can be defined as an imaging field where we try to combine between artificial intelligence, particularly machine learning and deep learning. And the seek is to carry out advanced spatial analysis to interpret and to analyze the data. So it could be applied to various types of data. It could be applied to vector data, to raster data, to point cloud, 360 images, whatever you want. And this is why it is very important, because it comes at the intersection between the data, the spatial data, the artificial intelligence, and the use of GIS. 20? Oh, thank you very much. So I think all of you know this picture, which try to draw the relation between artificial intelligence, machine learning, and deep learning. I will go quickly on it. So just to understand that the purpose of artificial intelligence is try to imitate the human way of thinking in order to solve some specific problems. But when we talk about machine learning algorithms, so they have the same objective, which is trying to solve problem as human, but based on data. So we try to learn from data. And here we know, like I mentioned, that without being explicitly programmed. It means what? We use some pre-existing algorithms, we train them, and then we'll get some model, and then we'll apply it to a specific solution. So the model, the algorithms is there. And just to know that the fact of doing programming with ML and DL it's not complex at all, because the structure, the architecture is there. There are researchers who provided us with those architecture. And we need to know how to train them in order to get a model for a specific example. And in our case, we will talk about 3 examples that we've used that I will present to you in this presentation. The difference between machine learning and deep learning models, that deep learning models are mainly based on artificial intelligence with a deep number of layers. So we have based on EANN, artificial network, but with a certain number of hidden layers. We need to have a depth on our model to consider it as a deep learning model. Otherwise, it will be considered simply as a multi-layer perceptron. So the workflow, before digging into the examples, so the workflow is always like this. We need to prepare the data, collect the data, and we need to do what we call phase of data labeling. I will use this one specifically. Data labeling, it means preparing the data for the training process. Then we train our model, which we need to choose a specific algorithm, a specific architecture to train it in order to do the inference. And in this process, there's iterations, because it's not always as the first time that we will get the good results. We need to do iterations 1, 2, 3, 4, and also some trial in terms of parameters in order to get a good model for our specific analysis. The good news, let's start with the bad one. This process is very, very it takes a lot of time, and it requires also data, a lot of data. if we want to have a good model to do, like, for example, detecting building footprint, or, for example, the examples that I will show you, parcel delineation. So we need a lot of data, and also we need time to train the model. The good news, 10? Okay. So the good news is that, the good news is that we can have what we call pre-trained models. Pre-trained models. So pre-trained models, that some models have been already trained, some researchers, some companies, and then either we can use them directly without any training process, or we can do what we call fine-tuning using transfer learning. It means a way to train it, but just with a few samples of data instead of having like a big number, a big volume of data. And it's very like powerful method to try to like overcome the problem of having a big volume of data in order to train the model. So let's start with the first example, which is parcel delineation. I think all of you know the importance of parcel delineation because parcel delineation is crucial for MPC. It provides us the base layer, which is the parcels. And based on the parcels, we can add all other related information about the land. So the problem is that the manual parcel delineation offers precision. We know that. We know that the precision provided by manual delineation is very high. Well, again, it is a slow process. So it is important to like find like a balance between the accuracy, which is related to the time, and the affordability. And more particularly, I want to stress the fact of having a scalable solution. So in order to choose a cost-effective method for parcel delineation, particularly if the problem of accuracy is not important at certain like time or at certain like for some specific purposes, we can, for example, accept that we have a delineation with 1 meter of error or 1.5 or 2 meters. So perhaps this method will be very effective in terms of providing parcels like just by applying the algorithms that I will show you in like a large area. But if we want to have like precise delineation, then perhaps we need to go to the classical methods, which is mainly digitizing. Okay, so I will show you the results that come from 3 models that we've tested. So this is a work that I've supervised with some of my undergrad students. And we tried to test 3 algorithms. So the first one is UNIT. The one of you who work with AI and DL, they will know that this is a convolutional network with an architecture of encoder-decoder for doing what we call semantic segmentation. The second one is TransUnit. So just to tell you that it is based on the famous logic of GPT, which is transformers. So it is, we have a visual transformer encoder, and we have a decoder. So it is similarly to the logic of encoder-decoder, but we've added, not me, but the researchers who provide this model, they've adopted the same logic of encoder-decoder, but with introducing the visual transformers. And the third one, which is DeepLab v3 with DenseNet as a backbone. This one, it is a backbone. When we talk about backbone, it means it's an already pre-trained model that we can use in our architecture, which is a good thing because it has been already trained on like open a huge data set of images. Okay, so these are the 3 models, and we've applied them into two areas. So the first one is an urban area, and the second one is rural area, and we want to check that it's like accuracy in both environments, in the rural and the urban. And you will ask me why you've choose a location which is called Goose Creek Village in the United States, simply for the data, because we don't have data to apply it in Morocco. We hope that, but we found open data for a specific region in the US, and we've tried our model. If we have the data in Morocco, it will be the same logic or another Arab country. So this is the area. 5? Okay. So we have the data to be where we will do our test. So which is an ortho image data with 1 meter RGB within infrared, so 4 bands. The people who are working on remote sensing, they know that the fact of using near infrared, it means that we can split between, will detect the vegetation. So because here we want to do the partial delineation, and we know that the vegetation has an impact on partial delineation, so we introduced the near infrared also. And this is the data that we've used to the training process for the urban area. For the rural area, so it is a region in Middelkoop in Netherlands for the same reason, data. And we found an open source data to train the model. It's an AI for boundaries, a data that has been prepared for the sake of training those kind of models. We've applied them on the same type of images, and we have the results. So here we have the results. This is the result of our model after the training. Here we have the validation and training process. Quickly, just to understand that our model works perfectly without any overfitting problem or without any underfitting problem. I will not go into the details about this fact, but I want to mention here the very high result that we've obtained. But just to be frank with you, those results, 99%, 98%, it is based on the number of instances. So the numbers of pixels that we've detected are exactly the number of parcels that exist. So we will work, because it's an ongoing project, so now we will try to add other metrics related to the area and to the perimeter of the parcels. So to be sure that we know that our model can extract data in terms of the number of parcels in a very excellent way, but the question is, what about the perimeters, area? What about also the length of the parcels? So this is the question that must be investigated. And here it is just like examples of results. So we have here, for example, images from rural area. We have the ground truth, and we have the prediction, and we have the parcels, the number of parcels. So, and we've applied the same logic now for the urban areas. So the results in the urban area are less than rural area, and you know why? Because in the urban area we have buildings, and it will be much more difficult compared to the rural areas, but the results are also very interesting. And here you have some examples on the results. Okay. The second, how much you have? How much time? Two. Okay. So this one is a forecasting, urban growth forecasting project. It has been published on a paper, I think, in 2024. I think land urban policy, if I'm not wrong. So we've applied our algorithm on the region of Casablanca, and the purpose of this algorithm is what we call forecasting. So urban growth forecasting based on AI. This is the logic. I will just focus on this part, which is the convolutional LSTM, convolutional long short-term memory. It's a very known algorithm for the wind forecasting based on images. So we've prepared a set of land use land cover maps based on Sentinel images. And here we have the Sentinel images that we've used. I think we have around 13 or 14, if I'm not wrong. And we've applied this. And then we've done a prediction. We've done a prediction on 2021. Why we've done this prediction on 2021? Because we know already what is the urban land use land cover in 2021, so we can compare between the predicted land use land cover and the real land use land cover. And I will jump this part. I will jump the algorithm, and we have the results here. So here we have like the true positive, true negative, false positive, false negative. I will go directly to the kappa, which is 95%. And just to also mention that this is a binary classification, because here we have two classes, building or not building. So we want to improve the algorithm in order to have multi-class like urban growth instead of having only one. So in 1 minute, another solution. This one is the SaaS, the software as a service. So it's called Mapersive. And we can do extraction for street furniture, for example, information about the buildings, about the streets. Just we have 360 images. We can upload them in a fully cloud solution, starting from doing anonymizing algorithm by AI, segmentation algorithm by AI, doing some kind of computer visions, and then creating tools doing tour navigation in an immersive way and doing the extraction. So here I have a video I think, just to show you how we can do the process. So here we have some already extracted data, and here I will show you how to do the extraction. So we can click on the objects from 2 images, and then we can add the information that we want. And after that, we'll populate a database that can be used directly in a GIS environment. So here we have, for example, the location of electric pole. And here we have semantic segmentation. In fact, it's panoptic segmentation. Panoptic segmentation, it means we know the number of instances in addition to the classification. So we can, for example, count here that we have, for example, 10 people, 8 cars, etc. And we have also here, yeah, I will conclude. This is the last one. So here we have point cloud generation based on the solution and also the semantic segmentation of the point cloud, where we can, for example, count the number of our palm trees here. Thank you very much.
Thank you all so much. Everybody's presentations were great, and you can have further discussions on the bus tonight. And also we have tomorrow, go and find these folks, talk more about it, connect, exchange business cards, and thank you so much for joining tonight.